Okay, in problem 90 we have to compare real versus an ideal gas law. So we did ideal first in letter A, and we have 0.5 moles times the R times the temperature, which is 298, over the 10 liters, and you get 1.224 atmospheres. And then we use the ideal equation, the real equation, and we have to find the A and the B, which are given to us in the chart. And remember, A is the correction in pressure because the particles don't just hit against the walls, they hit against each other. And depending on how many particles there are and how much space there is, they're going to hit each other more or less. So that's what this part of the correction is. And B is the correction for the particle size themselves. It's in liters per mole, or their volume. And the number of particles. So we see that the more particles there are times this correction for the size of those particles needs to be subtracted out from this actual space that the particles have. So anyway, substitute into the equation, and we find in this case that the pressure is 1.223, which is very close to what we got, 1.224 over here. I mean, a lot of you guys would probably just round that out and be like, it's basically the same. So what we see is in this bigger container, the pressure is a lot lower, and we only see an 8% difference between a 0.08% difference between the two pressure values. So, but if you compare it to number 89, there was a 0.91% difference. And so what we see is that gases are more ideal at lower pressures, like in this problem, because we have a big volume, and they're also more ideal at high temperatures. In these two problems, the temperatures were the same, but those are the two conditions which allow a gas to behave more ideally. Thanks.